So this is section 2.5b. It's the second part called function operations. So all function operations are if you're given multiple functions that you do different operations like add, subtract, multiply, divide, and so forth. And we're going to talk about something down here called composite. Okay, so sometimes you might have three functions. Maybe I have f, g, and h, and maybe I would have f minus h, and I would just choose those two. All right, but here we're just going to have two. This is more like what you would see on a test, that you would be expected to do on a test. So let's just take a look here. So this is saying, here's my two functions. You're given that. Find f plus g of x. All right, so that just means add them together. So what this means is take 9x minus 2 and add a negative 3x plus 8. So we're just adding those together. All right, so what is 9x and a negative 3x? Well, that's a positive 6x. What's a negative 2 plus 8? Plus 6. So that would be your f plus g of x. That would be the answer. That's all it is. Now, let's say that you were given this, f plus g of 2. So what do you suppose it means when I have a 2 here? It means I'm going to find this answer and I'm going to put a 2 in for x. All right, so we put a 2 in right here, so 6 times 2 plus 6. So f plus g of 2 would be 12 plus 6 would be 18. And that would be your answer. Now here's what I don't want you to do. I don't want you to take this 2 and just put it in here and in here and then add them together. You're gonna have to be able to show me by hand how to add these together just like this, these exact steps, and then putting a 2 in, all right? So this one is f minus g of x. So that means you subtract. Now you have to be really kind of careful on this because, let me get my papers here so you can, all right. So when you have a negative, because you're gonna have to distribute that through. So, and also keep in mind the order. This could say g minus f. So I would take this one minus this one. The order is important. But this one says f minus g. So let's take f. So this is going to equal f, which is 9x minus 2. I'll just put it in parentheses, minus a negative 3x plus 8. So what I have to really be cautious of is this distributing this negative through. So here we're going to be left with 9x minus 2 plus, that becomes a plus 3x, and this becomes a minus 8. You're distributing that negative through. So f minus g of x is equal to 9x plus 3x, negative 2 minus 8, negative 10. Okay, now this time I didn't put a number in there, so this would just be your answer. It's not just a numerical answer like 5. It's got a variable left in it, and that's fine. That's what this means. So let's look down here at the multiplication. So let's do a multiplication. So f times g. So here we take 9x minus 2 times a negative 3x plus 8. So we're just going to multiply. So you can, whatever's easiest for you to multiply. I don't care how you do it. Distribute it, multiply it, stack it, whatever you want to do. Okay, so let's multiply this through. So 9x times a negative 3x. Okay, that's going to be negative 27x squared. 9x times 8 is a positive 72x. Negative 2 times a negative 3 is a positive 6x. Negative 2 times a positive 8 is a negative 16. So we'll combine those like terms in the middle. So it'll be negative 27x squared, 72 plus 6, so plus 78x minus 16. And that's it. Okay. Now if I did something like this, and this might be in the very beginning, and that's fine. This might be what you start with. This is what I give you at the very beginning, but I still want you to show me these steps first. Then I'm going to put a negative 1 in. So if we put a negative 1 in here, and a negative 1 here, what would we get? This would become a positive 1. So we would have 27 minus 78. I'm just going to put it above it because I'm out of paper here. Minus 78 minus 16. So what would that be here? This would be 94, negative 94. So f g of negative 1. 94, what is that? Minus 27. 60. You're going to have to help me out here. 67, drawing a blank. Negative 67, I believe. Okay, you can check my arithmetic on that. Negative 67. All right, so let's look at the division, f divided by g. Again, beware of the order because it could be g over f. I just didn't write those, but it could be g over f, so pay attention. So here's your f over g. And that's it. That's how simple that is. You know, sometimes these could be where they're factorable and you could cancel out, but we're just kind of working with the basics of these just to get a feel, because we're going to be doing lots of operations with functions multiplying, and eventually we'll divide these where we have to factor them out. All right. And so we'll get to that a little bit later. So that's more what you'll see right now for chapters 1 and 2. All right. All right. So composite. So what composite means. So this is composite. And that's what this little circle is. That's really not the word fog. It looks like it, but this is just a composite circle. So it's F composite G. So what composite means is I'm going to substitute one function in for another. So, and it's always the second into the first. All right. So it's the second function into the first. So we're going to take this function right here, and we're going to substitute it in for X into this one. So when I do that, let me go ahead and, well, okay, so we're going to have a 9. And then in place of the X, we're going to put the whatever G is minus 2. So this is F composite G of X. All right, so we took this and we put it in for X right here. And then we finished out writing the equation. So that's what we did. Put it in place right here. So then we just simplify that out. So 9 times a negative 3, negative 27x, 9 times 8 is 72, minus 2. So here we have negative 27x plus 70. And that's our F composite G of X. Okay. It's that simple. Now, if there happened to be a number in here, then I would go in, if the number would show up right here, then I would put that number in at the end. All right. So let's look at G composite F. So what's the difference? Well, this one is saying substitute F into G. So F goes into G. So again, so now we're going to take 9x minus 2, and we're going to put it in right here for X. All right. So our G composite F, kind of see if you can see both. There we go. So F into G. So we're going to come over here and write negative 3. And in place of this, we're going to put F, which is 9x minus 2. And then we'll just simplify that. Okay, so G composite F of X is equal to negative 27x plus 14. So you can see they have different answers when you do composites differently. So you really need to pay attention to that as well. All right. One thing I wanted to show you, F composite G of X, you might see that notation written differently in MATLAB. I can't remember for sure how they do that, but it would be, let me just see how it could be written like this. I think that's how they write it. X could be inside of there as well. That's kind of the same thing. Okay, they may not use a composite sign, but just substituting G in. So if you see this, it's the same thing as a composite. It's this one substituted into that one. Okay, so just be aware of that. I think that's how they would write it. So anyway, this is what I'll be doing. I just don't know for sure what MATLAB has on it, so double check that. All right, guys, thanks. Have a good one.